Okay, welcome to Chapter 1 here. First of all, let's welcome you to the course here um, in the virtual world, Meteorology. I want to get you started here. Chapter 1 is a very short lecture. A lot of my lectures are going to be um, getting updated as we work our way through the course. So what I want to get you started here, first of all, is a brief introductory to meteorology and why we actually even study it. It pretty much, in a nutshell, it rules your day. Everywhere from sunshine to rain to snow to sleet, gives you a snow day, it gives you a flood day, it gives you a beautiful day at the beach. So hopefully by the time you're finished with this course, you have a true understanding of what is happening outside, plus you have a better understanding of how hard it is to forecast, especially for this area in central Pennsylvania. Now, take a look at what meteorology is. It's a study of the atmosphere and its phenomena. It's just totally cool when you think about it. And basically, you go back, we've only been keeping records for maybe about 130 some years, plus or minus 10 or 15, depending upon your geographical area. And one of the key things, a lot of this was introduced through time and transmitted. And you got to remember, as technology has advanced, we went from being 3 day forecasts to 5 to 7 out to 14. So one of the key things as we were moving on as a civilization, we let everyone know in the western part of the United States would let the people know in the east what was coming back in the early 1900s and so forth. So it was a big part of conversations too as we take a look at it. Take a look here, some more information. In the 20s, the concept of air masses and fronts were formulated by the Norwegians. They developed a theory of the evolution of mid-latitude cyclones, and that's what we see today when we have these areas of low pressure that move through. World War II, we started using radars, and they became a major part of our development that we see. Now most of us have a mobile device, and we just click on a weather app, and right there's a radar screen. 50s, we started getting computer guidance, and you're going to do a chapter dealing with computer forecasting, and you're actually going to sit down and do a 7 day forecast for me. In the 60s, we had our satellites. In the 1990s, the National Weather Service was modernized, and it's growing with better technology as we work our way through. So weather is expanding. It's becoming more and more easier for all of us to have access to all of that, and you're going to find that out through this course. Take a look at the atmosphere. It's very thin, pretty much in a nutshell. 99% of the atmosphere is in the lowest 30 kilometers. Okay, and if you take a look here, taking a look at the Earth's radius, it's about 6,400 kilometers altogether. But most of what we breathe is right here at the surface. And if any of you have been to higher elevations, you have a really hard time sometimes breathing because all our oxygen and our air molecules are closer to the surface. Gravity works that way. Composition of your atmosphere is your roughly 78% nitrogen, 21% oxygen, 0.9% argon. And then if you take a look in your textbook, depending upon what version you have, that's one thing you're going to notice with the PowerPoints. Some of you are going to have older editions to your textbooks. Your pages are going to be off a little bit. So if you look around page 3, 4, 5, you'll be able to find these numbers too. And expand onward. Again, the first atmosphere was created roughly about 4.6 billion years ago. Mostly comprised of hydrogen and helium, we believe. Got to remember, we weren't around at that period of time. And what this was produced was from outgassing. So basically what happened, you had a lot of volcanism taking place. All these gases were released from within the Earth into the atmosphere. You started getting water vapor being produced too, because you have your hot gases, cool, condense it, you start getting precipitation. Carbon dioxide and nitrogen were also formed. So through time, geologic time, we take a look at all of this, the outgassing occurred into the atmosphere that we have today. Now, if we take a look, why are there more air molecules near the ground than higher in the atmosphere? Atmospheric pressure decreases with height in a similar manner as density. All right. So if we take a look at everything, think about it. I already gave you the answer ahead of time. It's gravity. Okay? That's one of the key things. Your air molecules are closer to the surface. All right? Gravity pulls them down. Most of you in physical science in middle school and high school did a lab, a very simple lab where you put air into a balloon, and it shows you that air does have mass. So those molecules will actually sink down towards the surface. So that helps you a little bit. Here's another cross section you take a look at here with your pressures and everything. All right, we use a millibar that you're going to find through the course. That's what we measure our atmospheric pressure with in that. And the pressure decreases with height. And just think about it being at the bottom. A bunch of you, like growing up as kids, we all go out in the yard, we play, jump in a pile, all right? The ones on the bottom are the ones that get the greatest pressure because there's more and more people on top of them. So the person at the top of the pyramid, doesn't have that much pressure exerted upon them. Here's a good example of our atmosphere. Troposphere is pretty much where all the weather occurs, down here where we are. Then you move up to the Tropopause, Stratosphere, Stratopause, Mesosphere, Tropopause, Thermosphere. The Mesopause there too as well. Taking a look through all of this here, all right, notice how your temperature profile, as you work your way up through the lower levels of the atmosphere, under normal circumstances, unless you have a temperature inversion, your temperature decreases. Then it increases, decreases, and then finally increases again. And here's our average height, as you can see on the left, kilometers, on the right, miles, and you have your sections of millibars too as well. We use them for reference. The troposphere, again, I just said the temperature decreases with height, extends from the surface to about 10 to 12 kilometers. Depending upon what season we're in, cold air sinks and it compresses. During the winter, the troposphere is not as thick in our area as it is during the summer. Weather occurs. The rate of temperature decrease is roughly about 6.5 degrees Celsius per kilometer. This is called what's a lapse rate, and we get into that in more depth when we get into the chapter dealing with stability. This is where the jet stream is located in the upper troposphere. And again, I said it's higher in the summer and lower in the winter. Top of the troposphere is called the tropopause, separates the troposphere from the stratosphere that we see. Stratosphere, not as exciting, extends from the tropopause to about 50 kilometers. And this is where we find our ozone that protects us. Peak concentrations of the ozone are roughly about 20 to 30 kilometers above the surface. And again, the temperature increases with height. The mesosphere. That's bounded by the stratopause from below and the mesopause from above. Not much else to say about it. Thermosphere, the layer above the mesosphere, temperature increases with height, as we see at the top. And again, what I said, what we're going to be studying here all occurs in the level that we are in, which is so unique about this science. Weather versus climate. This is one thing we hear a lot that people will discuss back and forth, and what's weather, what's climate, and so forth. But if we take a look, weather is the state of the atmosphere at a specific time and place. Right now, I'm doing this recording. It's a warm, humid day. Sitting outside. We just had torrential rain yesterday. That is weather. It's roughly about 81 degrees. The dew point is roughly about 62. The winds are west at about 2 miles an hour on my weather station. Okay, that's weather. Climate, it's the average weather over a particular region. And like for our region here, we have 4 seasons. All right, we have typical during the summer, we have warm, humid days because of our geographical location. We get that maritime tropical air surging in from the Gulf and the Atlantic. During the winter, because of our location, we get a lot of continental polar air coming in from Canada. So that's an example of climate. So here for weather is characterized by air temperature, pressure, humidity, clouds, precipitation, visibility, wind. Climate can change, but over long time scales, years, right? So if you can measure it, pretty much going to be weather. Which of the following statements relate more to weather and which relate more to climate? We have, and here I give you a list that you can take a look at. You can pause and take a quick quiz on this, see what you're at. Here's your answers. Hopefully you got them all right. Now, for review, to help yourself do the review questions and answers, the answers will be posted in the weekly folders in the course. What I do is I have the review questions for you, or different types of review questions that are there with answers, and you can find them in each chapter in the assignment section for you to study. I highly recommend you use the Quizlet app there. It's located in there. There's a bunch of questions you can go through. Also, if you take a look on the news feed in the book, so you do not have to pay the course content fee for this. I have the 10th edition listed there in the news feed. You can take a look at that for free. You can go in. It has flashcards, quizzes you can do to help yourself for reinforcement. One of the key things, if you need to get a hold of me, it's quickest to email me. Add information on the news feed, also on the syllabus. Again, if you have any questions, just let me know. Alrighty. Thank you.